Hello everyone, welcome to Parthiva Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 24th April 2023. The problem statement for today is nearest smaller town. This problem has been asked in Atlassian interview. Let's now open this problem to solve it. Let's go through and understand the given problem statement. The problem statement says, given an array where each element represented by array of I represents the height of the tower. Find for each tower the nearest possible tower that is shorter than it. You can look left or right on both sides. In note it is given, if two smaller towers are at the same distance, then pick the smallest tower. If two towers have the same height, then we choose the one with a smaller index. Okay, so here it is saying that we will be given with an array where each element represents the height of the tower. We have to find the shorter, that means the minimum possible height of the tower that is shorter than the current which is in reference. Okay, and that can be present either on the left or at the right of it. And for this one, just to solve and resolve confusion that which one to take, in note it is given 2 points. If two smaller towers are at the same distance, then pick the smallest one, and if the same height is there, then pick the one with the smaller index, because it is array. Okay, so this was the problem statement. Let's go through the examples here so that it becomes more clear to us. So here the first, it is saying that given input array, it consists of 1, 3, 2. So that means there are 3 towers, and height of all these 3 towers is 1, 3 and 2 respectively. So here the output is -1, 0 and 0. So you see exactly here in the output array, we will be sending the index position against each current index position of the tower that is shorter than the current index point in reference. Okay, so here you can see this one. If for example here the first tower is height is 1, and in all other towers which is on the right of it, we do not have any tower which is lesser than the height 1. So we mark it as -1, because this is, or you can say look at it in another way, that this is the smallest among all the 3. Okay, so if we look at this one, then if we compare this with this, then here the height becomes same here for this one here. So this we are not including here, and since this is the smallest one, so we mark it as -1. So that's why it is written here for index 0, no tower is smallest, so -1. Okay, for index position 1, we have got both 1 and 2 which are smaller than 3. So here we will pick 1 because it has the smallest value. Okay, so here this is coming here in picture when we go through the first note point. If two smaller towers are at the same distance, pick the smallest one. So both are at the same distance, that means one distance left and one distance to the right. So that's why we are picking the smallest one. So here the output is here. So we will be picking the tower with height 1. What is the index of tower of that height 1? This is located at index position 0. That's why in output it is 0. When we move to the second index, so here we can see that the current index position height is 2. We have one tower there where the height is lesser than 2, which is 1. So we have taken that index position, that is again 0. So that only is given in explanation as well. So for index 0, no tower is smallest, so -1. For first index, for 3, here 1 and 2 both are small and at the same distance, so we pick 1 because it has the smallest value, so 0 index. For second index, here 1 is smaller, so 0 index again we are picking. So the final output will be consisting of 3 indices. This is -1, 0 and 0. When we go through the second example, so here it says the given heights of all the towers is 5, 8, 3, 5, 3. So and the output is 2, 2, -1, 2, -1. Okay, so here again the way we have looked at it at the previous example, we will again look at it at the same way. So here in explanation it is given that for 0th index, Here 3 is the smaller, so index 2. Because if you compare 4 and 3, so this one, when we look at the right of this tower, so here we have 2 elements smaller than 3. So sorry, smaller than 4. So we pick that index position. So index position is 2, that's why in output it is 2. For again also, sorry, for 8 also, 3 is the smallest one when we compare it with the 4. For 8, 2 elements are smaller than itself, that is 4 and 3. But this one, since they are at equidistance, then we are picking the smallest one. So we are picking again the index position as 2. Since 3 is the smallest one itself, so that's why minus 1. 5. For 5 again, we have 3 on both side. Okay. So here we have privileges to pick the element which is on left and right. But here if you compare the index position, so since the both elements have the same height, that means both the 3's have the same height, so we will pick the element with the smaller index. That's why we have picked this one. So here this index position was 2. And for 3 again, it is the smallest one only, so we have taken minus 1. So that only is given in the explanation as well. So I hope this problem statement and both the examples are clear. So for solving this problem, we will be using a stack based approach to find the nearest tower for each tower in the input array. Okay, the approach uses two passes over the input array. In the first pass, it fills the left array by finding the index of the smallest tower on the left of each tower. It does this by iterating through the input array from left to right and maintaining a stack of indices of towers seen so far. For each tower array of I, it pops all the indices from the stacks that corresponds to the tower with height greater than or equal to array of I and updates left of I with the index at the top of the stack if it is not empty. So this was the first pass. In the second pass, it fills the right array, that means the array with the name right array by finding the index of the nearest and smallest tower on the right side of each tower. It does this by iterating over the input array from right to left and maintaining a stack of indices of towers seen so far. For each tower array of I, it pops all the elements from the stack that correspond to the tower with the height greater than or equal to array of I and updates right of I with the index with the index at the top of the stack if it is not empty. Okay. Then after these two passes are done, then finally for each tower A of I, it compares the distances of the nearest smaller tower on the left and the right sides and choose the index of the tower with the smaller distance. If the distances are equal, then it chooses the index with the smaller tower height. If there are no smaller tower on each side, then we will set the value to minus 1. Okay. So this will be the approach we will be following. So with this approach, I have just created one short explanation, trying to explain how it will be done. So if we look at this one, if you look at this second example, then I have taken the second example here. So here for this one, the left array will be this one, and for right array will be this one. For this one, so what we will be doing for each tower, let me just increase this. Yeah, so for each tower we will be looking on the left side. For left array we will be looking on the left side, that which one is of the smaller height than the current one. So if you can see, for for the tower for height 4, with height 4, we do not have anything on the left smaller than 4, that's why it is minus 1. If you look at this 8, then we have on the left of it we have 4, which is smaller than 8. And what is index position? Index position is 0. That's why we have added this left array contains 0 at index position 1. For 3 we can see that on the left side of it no element is smaller than 3. That's why it is minus 1. For 5 we can see 3 is the smaller element than 5, which is located on the left side. And what is its index position? Index position is 2. Okay. And when we go to the last one, 3, so here you can see on the left of it no element is having height, or no tower is having height smaller than 3. That's why it is minus 1. Similarly, for right array we will be looking at the right side. So if you look at this 4, then on the right side of it which is the tower with the height lesser than this, then we will get this one, index position 2, because it is height, it has the height 3. Okay, so 2 comes here. 8, for 8 also same thing, 3 is smaller than 8, so that's why that index position, that is 2. For 3, this is the smallest one here. When we look at this right, so no element on the right is smaller than 3, that's why -1. For 5, one element is there on the right side which is smaller than 5, and what is index position? Its index position is 4, that's why 4 it is there. And at last, for 3, you do not have anything on the right side, so and that means no element is there on the right side which is smaller than 3. So here this one is having that index position as -1, which represent, if you look at the distance wise, then it represents the maximum height in maximum value of the integer. Okay, so now if you try to look at this one, this is there, and if you try to, let me copy the output as well here so that I can explain it. So out of these two left and right array, we are getting, we are getting this output. So what exactly we are doing? We are just comparing index by index. Okay, let me just align it properly. Yeah, so here we are comparing index by index. So as I said, as the last point of this explanation, that -1 represents the infinite value of integer range. Okay, so if you compare this one, if you compare the values of all the index element based on this one, that means here we are doing 1-to-1 comparison. That means here we will compare the element which is there at -1 and which is there at 2. Okay, so here -1 represents the maximum element, so that means the height of the tower is maximum, so big. When we compare with that 2, so what is the value? So what is that here? So if you look at this one, the index position at 2, we have got height 3. So which is the smaller one in these two? So the smaller one is 3, that's why we have got this one. We are out of these -1 and 2, we are selecting 2. So this is that value here. Again, when we look at 0 and 2 for second tower, for 0 and 2, what is the value at 0? It is 4. What is the value at 2? It is 3. Which is the smaller one? A smaller one with index 2. That's why we are selecting this 2 here, and that is coming as the output. For third tower, here in both these array we have -1 there. So again we are taking that -1 itself here. When we move to the next tower, here we can see left array contains index position 2 and right array contains index position 4. So here we compare the index position of this one. So here we'll see, if you compare in left arrow, at index position 2 we have 3, and index position 4, here again we are having 3. So both, if you compare which values are there at index position 2 and 4, we are getting 3. But we have to take the one which is having smaller index if the height is same, which is there in the second node point. If two towers have the same height, then we have to choose the one with the smaller index. So that's why we are choosing 2 here. And at the end, both array again contains -1 and -1. So here again the output array contains -1. Okay, so this way we will first compute left and right array, and we will just compare each element, each corresponding each element from both the arrays. That is corresponding element at same index position in both the array, and whichever fits according to those two node conditions, we will pick that index position and we will add it to the output or the resultant array. That's it. Okay, so with this approach only I have prepared one solution. Let me just copy it here. Let me move to Java editor. So so this is the complete solution of it. So again, all the logics whatever we have used here, that is again the one which we have discussed in the example. The same way we will try to compute a left array, then right array, and we try to do some comparisons based on that we decide which one to pick, the index position from the left array or index position from the right array. Okay, so this is the one. So okay, I'll explain it line by line. So here what does it do? First it initializes two array, that is left and right, both of size n, the length of the input array, and we are filling them with 1. These arrays will later store the indices of the nearest smaller tower on the left or on the left and right of each tower in the input array. Okay, then we are using here whatever the code is there, the code uses a stack to find the smallest tower to the left of each tower. So first we are trying to find all the elements of the left tower. So here it is we are using a stack to find the smallest to find the nearest smaller tower to the left of each tower. It starts by iterating over the input array from left to right. For each tower it pops element from the stack until it finds a tower with a smaller height than the current tower of the stack. Okay. Then but if it is not empty, the index of the top element is stored in the left array for the current tower, and finally the index of the current tower is pushed onto the stack. Okay, so this operation we are doing for the left one. So similarly, the similar operation we will be doing for same approach for the right tower. Before that we are just clearing the stack so that it can be reused. So here again the way we have done in the previous for the left array, the same approach to find the nearest smaller tower to the right of each tower. It starts by iterating over the input array from right to left. Okay, and for each tower it pops element from the stack until it finds a tower that is smaller than the current tower or the stack becomes empty. If the stack is not empty, the index of the top element is stored in the right array of the current tower, and finally the index of the current tower is pushed onto the stack. Okay, once that is done, then we are creating a resultant array, that is result array with the size n. Okay, then what here before to this one, so after left and right arrays have been populated, here we are initializing an array result of size n to store the indices of the nearest smaller tower for each tower of the input array. Then it iterates over the input array once again for each tower. It calculates the distance to the nearest smaller tower to the left, that is represented by left distance, this one, and the nearest smaller tower to the right, that is right distance. If the left distance is smaller than the right distance, or if they are equal but the tower on the left is smaller, that means if the left distance the right distance is equal but the tower to the left is smaller, then the index of the nearest smallest tower to the left is stored in the result array of the current tower. So here again we are checking this condition, and if the values, if both are at equidistance, but whatever we have in the left array in comparison to the corresponding index position tower from the right array, if it is less than or equal to, then we pick the value from the left array. Okay, similarly if this is not the case, then if the nearest smaller tower on the right side is closer or has an equal distance and is smaller in height, then we pick the element, we pick the tower from the right array. That means index position of the tower from the right array. So here again we are checking that condition. That means left distance is greater than. See here we are exactly in these two conditions we are checking two conditions. If here for picking element from the left array, we are checking if left distance is smaller than the right distance, then directly take that element from the left array. If it is not the case, then and that means left distance and right distance are equal. Okay, here we are checking that condition. If both are equal and that means the height of the tower from the left height of the tower from the indices from the left array that is smaller than the height of the tower from the indices from the right array. If this condition satisfies, then we pick element from the left. Similarly, from the right in the next case, if the left condition is not true. So here we are checking if left distance is greater than the right distance, don't directly pick from the right one. Else, we compare if it is equal and element on the right side is smaller than the element on the left side. Then we pick the element from the right side. Else, we will set -1. Once this complete iteration is done, then we return result, which returns the final result array. Okay, so this was the complete coding part of it. I have even added comments against each line so that it becomes easy in understanding. Okay, so this was the complete code of it. Let's try compiling this code. So here we can see we have got correct outputs for this given example. Let's try submitting the solution. So here we can see it has covered all the test cases. So this problem has been solved successfully using Java language. So talking about this time complexity of the nearest smallest tower function, here in the time complexity is big of n, where n is the length of the input array. The function first creates two arrays left and right of size n, then it fills them with -1 in big of n time using a stack. And that means we are first filling it with -1, then we iterate over this stack and we fill it with the corresponding element, that means the required element from looking at the left and the right of it. Okay, so each element is pushed onto and popped off the stack at most once, so the total time complexity of this step is also big of n. Finally, the function iterates over the left and the right arrays once again to compute the final result array. This step takes big of n time as well, since each element is visited only once. So the overall time complexity of the function is big of n plus big of n plus big of n, which is again in the order of big of n only. Okay, so this was the Java solution. I have even prepared C++ solution. The logic is completely same. So let me just copy that code here. Only the syntactical difference between C++ and Java, whatever we have, that difference is there, and I have not added comments here so that it becomes easy in reading the code. So again here the same logic, we are creating left and the right array, then through stack we populate the element in the left array and the right array. The way we have I've shown in this example, the what will be the elements of left and right array. And once that is done, then again it's compared with the same thing, with again the same conditions based on those two node points, and we either pick the elements from the left array or the right array. And if both these conditions are not true, then we are filling result array with -1. Okay, so the logic is completely same, only the syntactical difference between C++ and Java, that only is here. Okay, so let's compile this code. So here we can see we have got correct output even with this code. Let's try submitting the solution. So even with C++, we have got all the test cases covered. So this problem has been solved successfully using both Java and C++ language. So I'll provide the link for this question and the link for the solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment, share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.